Okay, just going to do the solutions now for test 2 for PHYS1021, the test you recently did. Okay, let's get started. We've got a multiple choice answer sheet we'll be using, and I'll take it that we've read the instructions on the front. And so let's begin here. Compare the work needed to raise one 10 kilogram bag of sugar 2 meters and the work needed to raise two 10 kilogram bags of sugar 1 meter. Well, the force you need to just lift something is just equal to mg. So for the 10 kilogram bag of sugar, that force will be 10 times 10 equals 100 newtons. For the two 10 kilogram bags of sugar, you can lift them together, in which case it's going to be 20 kilos times 10 is 200 newtons. Okay, now work is force times distance. So in the first case, it's 100 newtons times 2 meters, which is 200 joules. And in the second case, it's 200 newtons times 1 meter, which is 200 joules. So the amount of work is, as you'd expect, the same, because lifting, just common sense says when you lift a 10 kilogram bag of sugar 2 meters, well, first you lift it 1 meter, then you lift it 1 meter again, which is the same as doing two 10 kilogram bags 1 meter. You lift one a meter, then you lift the other a meter. So it's the same. Okay. Okay, you do work when pushing a cart with a constant force. If you push the cart twice as far, then the work you do is. Okay, so work, again, is equal to force times distance. So if you take the distance and double it while keeping the force the same, then the work will double. So you do exactly twice as much work. Note, we're getting the easy questions out the way first. Okay, a job can be done slowly or quickly. Both may require the same amount of work, but different amounts of. The answer is power. Okay, power is the rate at which you do work. So if you do a certain amount of work in half the time, then the power is greater. The work is the same, but the power was greater because you did the work faster. Okay. Consider a problem that asks for the distance of a fast-moving crate sliding across a factory floor and then coming to a stop. The most useful equation for solving this problem is. Okay. Well, friction does work on the crate, and the work that friction does is the force of friction times the distance, right? And the total amount of work that you need to do is the amount of work that's needed to get rid of all the energy the crate had to start with, and that energy was half mv squared. It's kinetic energy. So there it is. Force times distance equals the change in kinetic energy. Okay? So that's the one. Lost all its kinetic energy. That's going to be your most useful equation. Okay, we've got rid of the easy ones now. A light aluminium ball and a heavy lead ball of the same size are allowed to roll without slipping down an incline. When each of the balls have lost the same amount of potential energy, which will happen at different times for each ball, the balls have the same what? Okay. Well, okay. I'm going to go with A. They have the same total kinetic energy. Why? Because they're rolling without slipping, they're losing potential energy, and all of that potential energy is turned into kinetic energy. Alright? Do they have the same velocity? No, they won't, because the aluminium one will be moving a lot faster when it's lost that amount of potential energy. Do they have the same momentum? No, they don't. Again, yeah, no, it's just energy. It has to be because of the conservation of mechanical energy. So number 5, we're going to whack an A in. And there's a familiar one with a slight variation. So we've got a BMW motorbike accelerates at a constant rate from 0 to 100 kilometers an hour in 8 seconds, and a Ducati does the same, but only takes 4 seconds. So the Ducati gets to the same final speed, but in half the time. The BMW is twice as massive as the Ducati, including the riders. Neglect friction and air resistance. What can be said about the average power output of the bikes and the work needed to accelerate each of them to the final speeds? Well, let's look at work to start with. The BMW is twice as heavy as the Ducati, so to get to the final speed, you've got the work needed is a half mv squared, so if you double m, it must need twice. So the BMW must need twice the work of the Ducati. So let's see. So that one said they did the same amount of work. No. The Ducati requires twice the work. Tick. The motorbikes are the same average, but the Ducati only required half the work. Yes, that's right. Oh, hang on, the Ducati is the lighter one. So that's wrong, because it required twice the work. It's the lighter one. So the Ducati only required half the work. So that's right. The BMW required half the work. No, because the BMW is the heavy one. The Ducati has more power and required twice as much work. No, the Ducati is the light one. Okay, so going back to C, which is the only possibility now, and looking at that, we say they have the same average power output. And this is true, because the BMW took 8 seconds to do twice the work that the Ducati did in 4 seconds. So the power output's the same, so it's definitely C. Now here's one that 95% of you got right, okay? Because you've seen it before. A child starts from rest and slides from the top down a frictionless slide. The height of the slide is 5.5 meters. What's the maximum speed when they reach the bottom? Okay, so this is simple. They start with a certain amount of potential energy, mgh, and by the time they reach the bottom, all of that is kinetic energy, a half mv squared. So we can cross out the m's, we can do a little bit of rearranging, and we're going to get v equals the square root of 2gh. All very nice and easy, and so we say that's the square root of 2 times 10 times 5.5, and at this point we bring out a calculator and we say the square root of brackets 2 times 10 times 5.5, close brackets, equals 10.488. 88 meters per second, and looking at the answers, that's closer to 10.5 than any of the others. So 10.5 is the answer. 7, C, 10.5. Now, the next question is exactly the same question, but only 30% of people got it right. So let's do the calculation here and see what happens. Now, the child starts with a speed of 3 meters per second and slides down. Naively, you might say, oh look, when they started from rest, they ended up at 10.5, so if they start with 3, they'll end up with 13.5. Not so. Let's see why. Let's look at their total energy at the start, and I'm going to just go all numbers this time. So their total energy at the start is their kinetic energy, a half mv squared, plus their potential energy, mgh. That is a half, hang on, half times m. M doesn't matter, so I'm just going to make m1, okay? It doesn't matter what the m is, it'll cancel out in the calculations. So I'm just going to make it half times 1 times v squared, which is 3 squared now. Half times 1 times 3 squared plus m, which is 1 times 10 times 5.5. So what is the initial kinetic energy? Initial total energy? A half times 1 times 3 squared is 4.5 plus 1 times 10 times 5.5 equals 59.5. The units would be joules. Okay. Now, they get to the bottom of the slide, and a half mv squared plus 0 potential energy, because they're at the bottom, is now equal to 59.5. So therefore, and that m is just 1 of course, so therefore v is equal to the square root of 2 times 59.5, and so multiply it by 2 equals square root of calculators, square root of the answer. Now I can't see how to do it. Let's just do it from the start. So square root of brackets 2 times 59.5 close brackets equals, and it is 10.908. So therefore that's the correct answer there. Okay, so 30% got that. Alright, the principles are really straightforward. To start with, we have some kinetic and some potential energy. In the end, it's all kinetic energy, so it must stay the same. So that and that are the same, and from that we can work out the velocity at the end. Now, this one is similar again. So we have a mass which slides along this two-dimensional frictionless track. Whee! Okay, and the vertical height shown in meters. So in other words, this point B is 5 meters above the ground. So it says if it starts with a speed of 10 meters a second, which of the other points does it reach? Okay, so again, just using the fact that velocity equals 2gh, the square root of, which just flows from, the potential energy mgh equals a half mv squared. That just leads to that. So the question you say is, if we actually don't want this one, we want it rearranged. So because we know the speed is 10 meters a second, how high will it get when the velocity is 0? In other words, as it goes up here, it's going to be slowing. It'll be doing 10 meters a second when it hits here, because that's the speed it started off with. And then it's still slowing. Where does it stop? Where does the speed reach 0? Because then, if it happens before it reaches the top there, then it'll just go back down. If it happens after it reaches the top, then it'll go down and up there. And if it's going fast enough, it might go all the way like that. So I'm going to rearrange this, and I'm going to say, therefore h equals a half. Now the m cancels out with the m, and you get v squared over g. And so the maximum height, if it starts at 10, we have 0.5 times v squared, which is 10 squared, 0.5 times 10 squared divided by 10 equals 5 meters. So it reaches a maximum height of 5 meters. At that point, it stops. Okay? At that point, the velocity is 0. So here we go, down, up, and B is 5 meters. Okay, does it reach C? No. To reach C, it would have to go higher than 5 meters, and it can't because it stopped there. And it goes back. So that's it, just point B. Oh, I forgot to put point. That's the answer to 8. And the answer to 9 is B. Okay. Now, this question is a force applied to a door 40 centimeters horizontally from its hinge will cause the same angular acceleration as twice the force applied at what horizontal distance from the hinges? Okay, so what causes an angular acceleration? A torque. So if we want the same angular acceleration, we must have the same torque. And torque is force times distance. So what we have is we have force applied at 40 centimeters must be equal to twice the force times, well, it's going to be 20, isn't it? So therefore 20 centimeters is the answer. Okay, so question 10 is B. Alright, then another torque question here. We have uniform bars with force acting on them as shown, and there's a hinge here at the left, or pivot, and so we want to order the torques. If we take torques, the correct ranking of the size of the torques, largest to smallest is, okay, well again, torque is force times distance, but that's only if the force is at right angles. So here's the distance, D, and there's the force, but if it's this situation here, then you have the distance there, you have the force here, but you're only interested in that component of the force that is at right angles. So this would be force D sine theta. No, that was theta, not sine theta, cos theta. But the point is, we're told here that the vertical component of the force is the same in all cases. In other words, that is the same. So really, looking at this, we just have these two, where the force is being applied at this distance, and we have these three, where the force is being applied at half the distance. These are at different angles, but the vertical component, the component that matters for torque, is the same in each case. So these two will be the biggest, and they're identical, and these three will be next biggest, and they're identical. So that's E. That's question 11E. And there you go. First time I was brave enough to choose an E answer. Right. Now we move on to Ralph's questions. Two uniform spheres are made of the same material. One has a diameter twice that of the other. The ratio of the volume of the large sphere to the volume of the small sphere must be, okay, well, volume is equal to 4/3 pi r cubed. Now, the diameter is twice that, so the radius is half the diameter, so it still means the radius of the large one is twice the radius of the small one, and that's not squared, that's cubed. So if we double something and cube it, then instead of r times r times r, we're going to have 2r times 2r times 2r. So this is r cubed, and this is going to be 2 times 2 times 2 is 8 r cubed. So the large sphere will have 8 times the volume. 12. E. See, Ralph's not scared of choosing the outside ones. Okay. Which of the following options is correct? All atoms are composed of equal numbers of protons and neutrons. You know that's not true. Equal number of neutrons and electrons. That's not true. Equal number of electrons and nucleons. Definitely not true. Equal numbers of electrons and protons. Yeah, that one's good. Hey Lee.